This is a review, a short review that we did last time. We talked about chemical reactions. And we said you can add reagents together. You will make an observation. This is what you are going to do to watch on video. And based on your observation, you decide what sort of chemical reaction you have. And then based on what we learned before, we learned about single replacement. And then we learned about double replacement. And we learned about combustion reactions. So based on those, I don't know why Zoom is saying I am Parvin Carter. Parvin Carter is my wife. I guess because, I don't know, I have to re-sign into Zoom. So I'm not my wife, by the way. So guys, the last reaction that we talked about was precipitation reaction. And what is precipitation reaction all about? You add two clear liquid together, you see formation of cloudiness, solid, insoluble solid, which is the case here as well. We look at this one. And today we are going to continue our studies of the chemical reactions, how to predict the product. So let me get my pen, electronic pen. And maybe I should get rid of my video. You won't need to see the ceiling of my room. So this is a precipitation reaction. We talked about it last time. And this was writing a balanced equation for combustion. We said combustion of organic compounds results to the formation of carbon dioxide and water. So the reaction that you observed, which resulted to a yellow precipitate, this is the yellow precipitate that you observed. This is not water soluble. That's why we wrote, this is the precipitate. We wrote S here, which means solid. It's not soluble in water. And then NaNO3 is the salt which is formed, and it is water soluble. So we write aqueous. The reaction resulted by adding NaI, which is a clear liquid, water soluble, to PbNO2, lead nitrate, which is also a water soluble. So if I go back to the previous slide, do you see this is a clear liquid? This is sodium iodide.
So it's a color?
I'm sorry?
The precipitation could be a color that forms out of the clear?
Yes, it's more than color. It's cloudy, insoluble, colorful, yes. So here, this is the precipitate, which is lead iodide. The yellow solid, which is formed, is the precipitate. Thank you for the question. So how did I predict the product of reaction? I said this is binary. It's composed of oppositely charged ions. NO3, there is 2 NO3 minus 1. And then NaI is also binary. It's composed of 2 oppositely charged ions. So we said when you have 2 binary compounds, you mix them together and you see a signal which is telling you there is a chemical reaction. Formation of solid is one of those signals. You see something is happening. Then you can predict the product by replacing, switching partners like a square dancing. So the ionic metal are going to replace each other because they both have positive charge. So Pb is replacing an A and you get PbI2. So Pb and I are now partners together, and sodium is going to replace Pb, becomes a partner with NO3. So this is the chemical equation. We want to make sure the equation is balanced. Whenever you write equation, make sure to balance it. And we did a balancing equation last time. So let's see if it is balanced. 2NO3 and 2NO3. 1 Pb, 1 Pb. 2 times 1, 2I, and 2 times Na, 2Na. So do you see the reaction is a balanced equation. So if I go to the next slide, we're going to look at another chemical reaction we haven't looked at yet. And that's acid-base neutralization reaction. Previously, on chapter 4, I gave you some definition of acids and bases. And we said reaction between acids and bases result to the formation of salt and water. So in this reaction, do you again see oppositely charged ions making an ionic compound? And here, HCl breaks down to H plus and Cl minus as well. So the positively charged ions are going to replace each other. So sodium is going to replace H plus. You get an A now being partnered with Cl minus. And H is going to replace an A plus. It becomes a partner with OH, so you get HOH, which is water. Now, do you see this equation is balanced? You have 1 sodium, 1 Cl on both sides, 2 hydrogens here, 1 oxygen, and 1 oxygen on the other side. So this is a balanced equation. So again, you're using the concept of, you're using the method of double displacement to come up with the product of a chemical reaction which shows observable changes. What is the observable changes when you react hydrochloric acid and sodium chloride together? Well, these reactions are heat releasing. You see the temperature changes. On the video, we measure the temperature as soon as we add these together, and you get change of temperature. Change of temperature is showing that there is chemical change. Then we write formulas for the product. Any questions so far?
Yes, I was going to ask if you see the hydrogen in the OH, I forgot what they call it, I can't think.
Right.
Is that always going to be acid base?
No, this is an acid.
Mm-hmm.
It's stomach acid. Acids are provider of hydrogen ion. This is a base because it's provider of OH minus. So if you see OH, hydroxide group, you have a base.
Okay, so that means that I could class, then that's how I would know if it was like acid-base reaction.
Yes. Acids are provided of H plus. Also, I give you a table of the acids on the test. It's on the exam. And the names are there. And how do I know this is a base? Presence of hydroxide ion.
Okay, thank you.
You're welcome, Jamie. Okay. So another type of reaction. So far we talked about combustion reactions, precipitation reactions, acid-base reactions. This is another type that you're going to observe on the video of this lab. And you will see changes, observable changes, which tell you there is a chemical reaction, and then you're supposed to write the product. So, for example, a typical redox reaction is reaction of iron with oxygen forming rust. This is rust. So, I'm going to go back in detail to examine how does redox reactions are happening. They're important reactions. In every cell of our body right now, there is reduction reaction going, which is producing energy for us to be able to function. But going back at precipitation reaction, I would like to talk about more detail of precipitation reactions, and then I go back again to redox reactions. What is the definition of precipitation reaction? It's a reaction which results to the formation of insoluble solid, as you see here. This is PbI2, which is not soluble in water. How do I know it's not soluble in water? I give you a table that you can predict solubility of compounds. And you will use that.